everyone, welcome back to YouTube classes. Here I am Divya with class 11 physics. Now today we are going to start with your 5th chapter, motion in a plane. Like your chapter 5, you know that physical quantities are actually divided into two, isn't it? Your scalar quantities and your vector quantities. Now what about your scalar quantities? Scalar quantities, you have already learned this in your smaller classes. Scalar quantities, one which is having magnitude only, right? So what do you mean by magnitude? What is magnitude? Let's suppose you are going to have a distance of 2 kilometers. Now in this, can you identify what is magnitude? See, this numerical value is going to be the magnitude and this one your unit. Okay, so one which is having only magnitude, you call it as a scalar quantity. And what about a vector quantity? One which is having both magnitude along with direction. For example, velocity I am going to write it as 2 km per hour towards north. Here direction is also given, so this is going to be a vector quantity, right? Now right in this chapter we are going to discuss about this vector quantity. Clear? Now to start with the vector quantity, first we are going to learn how we are going to represent a vector quantity, or what is the notation we are going to give for a vector quantity, right? Now let's suppose A is going to be a vector quantity. If it is a vector quantity, we are going to represent it as A, above which we are going to give an arrow mark. So always a vector quantity is represented with a arrow mark just above that. For another example, if we are going to write velocity, V is the representation. Since velocity is going to be a vector quantity, we will represent it as with an arrow mark above the letter, right? Now the same thing, that is how we are going to notate your vector quantities. Now this arrow mark, that is whatever is the length of this arrow mark represents the magnitude, and the head of the arrow represents the direction. Usually the concept is taken like that. For example, let us consider a body moving at a velocity of 2 meters per second towards north. Okay. Now, direction, how usually we are taking? We used to draw like this. This is taken as north, south, east and west. Now, what is given? It is given 2 meters per second north. So, north will be in this direction. So, we have to draw that 2 meters like this. The length will represent the magnitude, and head, what about the head? The direction. So, head will be given upward to us north. This is how you are going to represent a body moving with 2 meters per second velocity towards north. Got it? So that is how you are going to take it. The next question or the subtopic you are going to have is your position and displacement vectors. To understand what is a position and displacement vector, let us consider a Cartesian coordinate, x-axis, y-axis, origin, O. Now let P be a particle at a distance r1 from this origin O in time t1. Okay. Now let Q be another particle at a distance r2 from the origin at a distance of r2. Right? At a time t2. This distance OP, or the vector OP drawn from origin O to P, will be your initial position vector OP, and from OQ will be your final position vector. Okay, so the distance from the origin, or a vector drawn from the origin to a particular point that represents the vector represented by this, you got it as a position vector. Now we want to know what is a displacement vector. Now the displacement vector means the difference between the initial and final position vectors. You call it as the displacement vector. So what is a displacement vector? A displacement vector is a vector or the difference between the initial and final position vectors will give you a displacement vector. It's a zero vector or a null vector. Okay. Now what do you mean by a null vector? vector or a zero vector is that a vector which is having zero magnitude and having no specific direction. You call it as a zero vector or a null vector, and you are going to denote it as zero vector. Okay. Now, for example, if A and B are two vectors, a null vector can be represented as a vector A minus vector B giving zero vector, where vector A and B both should be equal in magnitude. Now when you come to the properties of this null vector or zero vector, it is giving as the usual properties. That is, if you are going to multiply a zero vector or a null vector with a finite vector A, you will get it as a zero vector itself. Okay. Now the second point, if you are going to multiply a zero vector with a number n, then also it will be 0. Got it? Now again, if you are going to add a zero vector with a finite vector, here also you are going to get that finite vector itself. So these are all we are getting, what we are doing with 0 plus 4, or in mathematics simple basic things, the same thing is being followed by a null vector or a zero vector. Now suppose you are having 2 or 3 vectors, vector A, vector B, vector C. Okay. So these vectors A, B, C are said to be equal or equality of vectors if all these 3 are having same magnitude and same direction. Got it? So equality of vectors means 2 or more vectors are going to be equal if and only if all the 3 are going to be equal in magnitude and in the same direction. So you can write it as A is equal to vector B is equal to vector C. Now let's suppose you are going to have another vector B equal in magnitude but opposite in direction. How will you represent it? Vector A is equal to vector B is equal to vector C is equal to minus D, or this one you call it as a negative vector. Okay. Now next what you are going to have is a unit vector. Okay. Now unit vector means, from the word itself it is clear, one which is a vector with magnitude unity or 1. You call it as a unit vector. Now unit vector, let us see how we are going to represent it. Let's suppose you are having a vector A whose magnitude should be non-zero, right? So then only it will be unity, starting from unity, isn't it? So suppose you are going to have a vector A with non-zero magnitude, you get then vector A divided by A will give you a unit vector A. So unit vector you are always going to represent it with a cap at the top. Vector you are representing it with a arrow mark in the direction, whereas a unit vector will always be represented with a cap on the top. Or you can write A is equal to A cap. Now what about the direction of this unit vector? The direction of this unit vector will be same as that of your given vector. Got it? Now, with respect to this, you are going to have a subpart, that is orthogonal vectors or orthogonal unit vectors. Orthogonal unit vectors. Now, this orthogonal unit vectors means this you are going to represent it in a Cartesian coordinate. So, Cartesian coordinate, x-axis, y-axis and z-axis you are having, isn't it? X, Y, Z. So if this is a Cartesian coordinate, then unit vector along x-axis is always represented as I cap. Orthogonal unit vector along y-axis will be J cap, and orthogonal unit vectors along z-axis will be K cap. So this I, J, K are known to be orthogonal unit vectors, where I is the orthogonal unit vector along x-axis, J is the orthogonal unit vector along y-axis, and K is the orthogonal unit vector along z-axis. So this is all about today's portion. So go read your textbooks properly and see whether you have any doubt in any of the portions given, and if you have any doubt, feel free to put it in the comment box. I will reply for that. So now, till you see the next video, take care, stay safe, bye bye.